Hey guys, this is Iz from Launchpad, and today I'm going to be teaching you how to make a super easy basic metronome circuit. So let's get started. So the brains of the circuit consists of this little IC chip right here. This is the NE555 timer chip, and if you remember from the theremin video, this is the exact same chip. So let's review how to read the pins on this chip. It's super tiny, but if you see the little notch at the very top, it's like a little semicircle. That is what you're going to use as your reference to remember what pin is what when building your circuit. So looking at the notch just on the top here, whatever is to the left here is pin number 1. So you count down 1, 2, 3, 4, and then go across 5, 6, 7, 8. And that's how you tell what pin is which. I will also attach a little picture here so it's a little more clear. But this is the brains of our circuit that we're going to be doing today. So let's go ahead and put this on the breadboard. Now if you don't know how a breadboard works real quick, there's a picture right here. Show you how the connections internally of a breadboard work. So before you start the circuit, make sure you know how a breadboard works, or check out my other video on how to build a theremin. So when putting this on the breadboard, we're going to want to put it over this little gap here because we don't want the pins to connect together, right? So let's go ahead and connect this chip onto the breadboard. And don't be afraid to push this pretty good in there. So there we go, our chip is in our breadboard, and if you remember, if you can see the notch at the top, just remember this right here is pin number 1. 1, 2, 3, 4, up, 5, 6, 7, 8. You can put it in whatever orientation you like. This is just how I put it on the breadboard. Okay, so now, looking at our schematic here, let's start making some connections. So the first thing I always like to connect personally is things that don't involve components, just basic connecting certain pins to ground or like to power, connecting two pins together, stuff like that. So let's start with that. So looking at our circuit here, let's trace from pin number 2. What other pin is pin number 2 connected to? 6, exactly. So let's go ahead and use a patch cable to connect pins 2 and pin 6 together. So here I have these small little patch cables. You can find these on Amazon for super cheap. And I'm going to use this to connect pin 2 and 6 together. So as you can see here, I have pins 2 and 6 now patched together. Okay, so now let's take a look at pin number 4. What other pin is pin number 4 connected to? 8. So we're going to do the exact same thing, but with pin 4 and pin 8. Again, taking just a little patch cable, let's connect pin 4 and 8 together. And there we go, pin 4 and pin 8 are now connected together. So the next thing that I'm going to do is connect our ground and power. So taking a look at the schematic here, this bottom line is for all the ground connections. So anything that is being traced down to that bottom line is connected to ground. Ground also stands for negative. So on your breadboard, if you see ground, it's going to be this negative blue line down here. Now for the top line, it's the exact opposite. The top line is VCC, aka power. If you look on the side, you see a little 9V with a positive sign, that little symbol right there. That's a battery symbol. So the top part, where it has the positive sign, is just showing to you that that's going to be all your positive connections there. And then the bottom side is the opposite, which is ground. So let's trace what pin is connected to ground. So let's take a look at pin number 1. It says it on there for you. It literally says ground on the little chip symbol. So we're going to do exactly that. We're going to connect pin number 1 to negative, aka ground. You don't have to color code your circuit with the patch cables, but I personally like to. Anything that's ground, I like to keep it black, and then anything that's positive, I like to keep it red, just for like clarity and organization purposes. And there we go, that black cable is going from pin number 1 into ground. So now we have to connect our positive connections, because so far pin number 1 is the only pin without any components that's connected to ground. So I'm going to move on from ground connections for now. Now we're going to trace what VCC is. So now let's take a look at all the connections that need to be connected to positive. So taking a look at pin number 8 and pin number 4, they're connected together, and then pin number 8 then goes to that top line, which we established earlier is positive, or VCC. So let's go ahead and make that connection. So again, you don't have to color code, but I like to color code personally, so I'm going to use a red wire to connect pin number 8. And there we go, pin number 8 is now connected to power. Also, another thing I like to do, I like to keep my positive and negative connections to opposite sides of the breadboard just to keep it more clear. You don't have to. Totally up to you, but always remember that this positive and this positive on the side are not connected together. So if you have some positives on this side, some positive on that side, you need to add a patch cable from this rail to that rail to make sure they're connected. But in my case, I'm just doing them on opposite ends, so it's easier in the end. Okay, cool. So now that is all of our connections that don't involve any other components, and now we're going to start adding some components. So this is the fun part. So let's take a look at pin number 7 and pin number 2. They have one thing in common, and that's there's a resistor going in between the two and then leading to that top resistor, which is a variable resistor because of the arrow, which is also called a potentiometer in this case. So anytime you see a dot on the breadboard, that stands for a node. A node is some sort of connection in its own area on the breadboard. So if you see a node, what I like to do for visual clarity is make a patch cable to a separate row on the breadboard that has nothing else connected to it. And if your circuit ends up not working, it's going to be super easy to troubleshoot because you made your circuit on the breadboard super clear to read. So I'm going to start off with doing a patch out of pin number 7 and a patch out of pin number 2 that'll eventually connect the resistor in between. So first I'm going to do a patch out of pin number 7. So find pin number 7 on your IC chip, and I'm just going to put it to an empty spot somewhere on the breadboard that nothing else is connected to. So like, here's great. This patch here stands for the dot node on the schematic. So it's just a visual clarity to know that, okay, this node has its own row on the breadboard. Now let's do the same thing for pin number 2 into an empty spot that nothing else is connected to. Not even pin 7 yet, because we're going to connect that later. So find pin number 2 on your breadboard and patch it somewhere close-ish because we are going to connect a resistor in between. And actually I'm going to move this over because I need a space for the resistor. This is what it looks like here, and then in between these two here, we're going to add that resistor that's on the schematic. So if you don't know, this is what a resistor looks like, and these are non-polarized. Non-polarized means that there is no positive and negative leg, so it doesn't matter like which orientation you put in the resistor. So let's go ahead and put this resistor in between pin 2 and pin 7, just like it shows us on the schematic. And there we go, the resistor has been connected in between these two patches that we put out of pin 2 and pin 7. Okay, so keeping on the same track in the same area on the schematic, we're going to trace what else that pin 7 node is connected to. So if you look at the schematic, you have pin number 7 connecting to that 1K resistor, but it's also going up to that variable resistor, aka a potentiometer. So we want to make sure that that resistor out of pin 7 and pin 2 is then going in to the potentiometer. This is a potentiometer. So there's 3 pins obviously on this, and when you're looking at it from this orientation, it's left to right, pin 1, 2, and 3. And when you're looking on the schematic, you have pin 1, 2, and 3. So in this case on the schematic, we want to connect pin number 1 to that node coming out of pin number 7. And there we go, we have the potentiometer connected to pin number 1, where that patch from pin 7 came from, and there we go. So now let's do the other connections that involve this potentiometer. So if you look at the schematic, you see an arrow pointing into the middle of the resistor symbol, right? So basically that's saying that we need to connect pin 2 and pin 3 of the potentiometer together. Alright, so we're connecting pin number 2 here, and pin number 3 together. And there we go, with that yellow cable right here, we connected pin 2 and 3 of the potentiometer together. So now, there's only one last connection for that potentiometer, and that's pin number 3 being connected to that top line. And as we established earlier, that top line stands for VCC, aka the positive power rail. So let's go ahead and make that connection as well. So here, I'm connecting pin number 3 into our positive power rail right over here. And there we go. So that's all the connections that we need for the potentiometer and that node coming out of pin number 7. Now let's check the other node that came out of pin number 2. There's one more component coming out of that node. So if we trace that node, that green cable, we saw that it was connected to that 1K resistor, which we already made right here. But now, if we continue downward, you see another component. This symbol that you see on the schematic there is called a capacitor. In this case, this is a polarized capacitor. And when something is polarized, that means that the positive and negative leg actually matter. Like there is actually a positive and negative leg. So as you can see in the symbol, there's a little positive sign to indicate where they want the positive leg connected to. In this case, the positive leg is coming right out of that pin number 2 node into ground, which is that bottom line. So let's go ahead and make that connection. So here I am grabbing a 22 microfarad capacitor out of this little kit here. And this is what they look like. So this longer leg here is always going to be the positive leg, and the shorter leg is always going to be the negative. So let's go ahead and connect this into our breadboard. We're going to connect the positive leg from the node that we made coming out of pin number 2 on the IC chip. So let's find that patch that we made and then connect the negative leg to that same row. So as you can see here, this is our patch that we made out of pin number 2 for that node, and we traced it. It comes over here where this resistor is, but then also now we have added this capacitor coming out of it as well. Looking at the schematic, the other leg of the capacitor, the negative leg, is connected to ground. So let's go ahead and do a patch into ground. So here I'm just taking this patch cable coming into the same row as that negative leg and popping it right into ground. There we go. So now we're done with that whole side of the schematic. We've connected both the resistor, the variable resistor, and that C1 capacitor. Now we're going to head over to the other side of the schematic, which is the stuff happening out of pin number 3. So let's go ahead and make those connections. So if you take a look on the schematic out of pin number 3, you see another capacitor, another polarized capacitor to be more exact. And this capacitor is also a 22 microfarad capacitor coming out of pin number 3. We're going to put this capacitor positive leg into pin number 3, and then the negative leg we're going to put into an empty space somewhere because we're going to eventually connect that speaker to it. So let's go ahead and connect the positive leg of the capacitor out of pin number 3. So as you can see here, this capacitor, the positive leg is coming out of pin number 3, and this negative leg I left into an empty row where nothing else is connected to, so we can now connect our speaker to it. So now, taking a look at the speaker here, there is no positive and negative that it shows, but we can infer that the bottom half is the negative side of the speaker because it's connected to ground. So this is the little speaker that I have, and if you take a look at the back, it shows you positive and negative. And again, with the color coding, red is usually positive, black is usually negative, so this is going to be super clear for us to take a look at. So looking at the schematic again, you see that the bottom side of the speaker is connected to that bottom line, which is ground, negative again, and then we can infer that the other side of the speaker is the positive, which is connected to that capacitor. Got my red wire. I'm going to put it into the same row as that capacitor that we put coming out of pin number 3 of our IC chip, and then this negative side is going to go directly into our negative rail. So now the full schematic is basically done, and the last thing that we need to add is our battery to actually power it. So when connecting the battery of the schematic, you're just going to have 2 patch cables, one red one for all your positive connections, and then one black one for all your negative connections. So this is why earlier I said I like to put my positive and negative connections on opposite sides of the breadboard because it makes it easier to connect the battery. So as you can see here up at this top line, I have all my red wires, which are all my positive connections. So I'm going to put that red wire at the end of this breadboard for all the positive stuff, and this will get clipped to the positive side of the battery. Same thing for the negative. I have all my negative black cables here to the negative. So now I'm going to put this negative wire here to connect to the negative side of the battery. If you have these alligator clips, you can use them to clip it onto your battery to make it easier and hands-free. If you don't have them, you could also simply just touch your wires to the sides of the battery that you need. Always make sure that you connect the correct sides to the correct sides. So negative goes to negative, positive goes to positive, because if not, it will start smoking possibly, maybe. So just make sure you're connecting it to the right sides. And on most 9-volt batteries, it has a little print that shows you the positive and negative side. So here on this battery, see that that side is the positive side and this other side is the negative side. So just make sure you're connecting them correctly. Okay, there we go. I now have connected these alligator clips to our little connections here, and you can hear the metronome going. And now, as you turn the potentiometer, it's going to change the tempo. And there you go, that's how you make a basic metronome circuit using the NE555 timer IC. Let me know if this works for you, send pictures, I'd love to see how your circuits turned out, and have a great day.